Good morning. Unpacking the title, we're going to look at socio-technical networks, people interacting through technology. It's multi-mediated because there's different ways they can interact. And the question is, what communities exist in those networks? This is work done with my student, Kar-Hai Chu, and also a shout out to Devin Rosen, who was on the project until last year. First bullet point doesn't need to be said at this conference. Obviously, learning is increasingly technologically embedded. One kind of motivating question is what the synergies are between individual and collective learning, or individual learning and collective activity, if you will. That it's relevant to look at the community settings in which learning takes place. And indeed, perhaps learning is also a social affair. So this question demands analyses that let us move between levels of analysis, connecting different levels of analysis of learning in particular times and places and what their settings are. What is their social-technical setting? So what is their social setting, other actors, and their technical setting? Through what media are they interacting? Take a little bit of a big picture here on learning before I go into the specific problem and analyses that I did. There's different theories about what learning is, and in particular about how being in a social setting fosters learning. So first of all, you can be primarily concerned with the individual as the agent of learning, but also small groups. Some theories take small groups as the agent of learning, and others take larger collectives as the agent of learning. There's different epistemologies. What's the process of learning? The process of acquisition of knowledge. Well, one of them is indeed an acquisition metaphor, that learning is a process of acquiring knowledge or skills. But learning is also seen as intersubjective meaning making. The learning itself is not an outcome, but a process to some theorists. And learning is also seen as participatory. The change of a person's position in a community, for example, through legitimate peripheral participation. So you see, there's different ideas about learning, and they all have to do with, there's different granularities, I guess, at which they take place. And I think this is actually partly a message for the field of learning analytics, that we need to be open to these different conceptions and also look at how they fit together. So I would argue that learners participate in all of these, for lack of a better word, levels simultaneously. You may choose to just study one, but it's good to identify the settings, the social settings in which learners participate, even if you're looking at individuals. So this is partly to motivate the fact that my talk is mainly about identifying communities. So what does that have to do with learning? Well, learning can be a community affair. The particular community or the particular social-technical network I'm going to look at is called tappedin. It was developed at SRI, which used to stand for Stanford Research International, but after they disconnected from Stanford, doesn't stand for that anymore. It just stands for SRI. And Mark Schlager, I think he was really ahead of his time, had great ideas about how to do this work, led the project. And Patty Shank and Judy Fusco were with him pretty much all the way through. It's been one of the longest running online communities, educational online communities. And I managed to get from them 8 years of data, 20,000 educators active a year. It's volunteer-driven, so there's about 800 user-defined spaces. There's tenant organizations. It uses a spatial metaphor, so there's like the tapped-in main building here, and different tenant organizations have rented out buildings where they conduct their activities. But it's all volunteer-driven. The tapped-in developers did not run the sessions. And it's multi-mediated. There's chats, threaded discussions, wikis, file sharing. Here's what part of it looks like. Kind of the default mode of interaction is chat, but you can also go to discussions and share files. This whiteboard is basically a wiki. So people have choices about how to interact, and collections of people have choices about how they will be a collection through the different affordances of this environment. Mark's on my advisory board, and one day in an advisory board meeting, I said something, I used the phrase tapped-in online community, and he said, well, it's a network. I don't know what communities are there. There's multiple communities maybe embedded in it. There's multiple tenant organizations. There's people who come on their own initiative. It's a fluid environment. People can join things run by the tenant organizations sometimes. So we don't really know what's going on there. And he was actually kind of frustrated that he had never been able to get funding to study it. And I did. That's why he's on my advisory board. So I realized I could help answer his question. I hadn't set out to do this originally in my grant, but I realized that what we had developed would fairly easily answer his question about what's going on there. So it's an empirical matter, what communities are there. So we're not going to assume that the network constitutes one community, and we're going to even assume that the tenant organizations will correspond directly to communities, although it turns out in some cases they do. We're going to look empirically to see what's there. So the approach that I'm taking is based on identifying clusters or cohesive subgroups of participants using a particular graph partitioning algorithm, and then looking at those clusters, the more interpretive component of the analysis to see if they make sense as communities, and then looking at the media through which they are taking place. So the relevance of mediation, this environment is multi-mediated. There's multiple means of participation. And we were inspired by an article by Lacope and Smeretta in the Social Networks Journal talking about how individuals' choice of media to interact with others reflects and reaffirms their relationships. Their particular example was you've had a child, who do you call up from the birth room? Probably pretty close to them. And by calling them, you're reaffirming that tie. Who do you send an email to later? So our thought here is that this idea can be applied to the collective level as well as the dyadic level. So communities are embedded in technological environments, and if there's multiple ways to interact, they'll make choices that reflect what kind of community they are. My example is going to be fairly simple. It's going to be looking mainly at files, discussions, and chats, but I think this is an idea that can be generalized to other settings. Okay, so what we do then is, the point here is that the approach we take identifies the clusters and their mediation simultaneously. It's not a separate step to ask what media do they use, because all media artifacts, all the digital artifacts through which people interact, are represented as nodes in a graph just like the human actors. We're using Latour's idea of actant, that artifacts and people, if you treat them empirically, not philosophically, but empirically as the same kind of thing, and then see how it works out, then it will tell you what kinds of things they are. I know that there's a critique of actor network theory of not valuing human agency enough, but this is just an empirical strategy. So we built an analytic hierarchy to meet some of our other research needs, to address the problem that activity is distributed across media. So sometimes what the participants have done is fragmented across different log files. So we reunite that into a unified analytic artifact. Another analytic problem that we're addressing is that log files record events, and that may not be the right ontology that you're interested in. You may be interested in interaction or relationships. So we need to be able to abstract to other levels of description. And also another need is that I see, this is another argument for different levels of analysis. A tie in a sociogram, or if you construct a sociogram out of binary ties between actors, you can see patterns that would be really hard to see looking at particular sessions, and that's valuable. But that doesn't tell you exactly how those relationships were established, what the interaction was, so we also need to go look at specific times and places. So these two approaches of analysis need each other, and we designed this hierarchy to approach that, to support that. So I actually presented this hierarchy at last year's conference and at the Hicks conference. Basically, we construct an abstract transcript that collects together events into a single artifact to be analyzed, and then we have a hierarchy of levels of description, and it looks like this. Suppose you have a log file of some sort. First, we replace those really detailed entries with, we abstract it to meaningful actions on the part of the actors. So suppose that these are 3 different people represented by the shading who are writing and reading messages in a forum. And then there's two directions of analysis that can be taken here. One is to one which is not taken in this paper, other work, is to find the observed relationships between those events. We call them contingencies, reflecting how human action is contingent upon its setting. That can include things like they were close together in time, they were by the same actor, one was a threaded reply to the other, there's a lot of lexical overlap, there's semantic overlap, and so on. You collect together all this evidence, you get a big hairy graph, and then you interpret that as evidence for what you're really interested in, which is uptake. So for example, that we can now see that somebody wrote a message, somebody read it and wrote another message, somebody read that, and this person was an integrative person who was taking up from all three. They actually read all three and they posted something. So that's the kind of thing that that shows you. Today's talk is based on a different representation, which I'll have to explain a little more carefully. In this event notation, a node represents an event, and persons and artifacts are attributes. In what we call a sociogram, which is really a bipartite multimodal graph, directed multimodal graph, we take those attributes out as nodes. So a person becomes a node, and an artifact becomes a node, and the event is represented as a line between them. So this is the event of message 1 being written by person 2. My pointer is showing there. Yeah, okay. The direction kind of represents a sort of dependency. So person 1 read message 1 at some point there. If you like to think in terms of state change or something like that, that's just a description of why the arrow goes that way. And so you can see that there's a cycle here which corresponds to the round-trip dialogue between two people. So you can find interesting structures in these graphs. But today what we're going to do is we're going to take this graph and run a cohesive subgroup detection algorithm on it to find how do people and artifacts cluster together, and then we're going to see if we can interpret those as communities. If you prefer to work with traditional sociograms, you can of course do transitive closure, folding out the artifacts and get a traditional sociogram like that. So last year's paper for details on that. Here's another example. This is actually from the actual data that I'm looking at, and this was one tiny cluster that was found by the algorithms. I zoomed in to see what was happening, and this sort of shows you what kinds of things these graphs can show you in detail. So these two nodes are actors. The ones that are showing up as green here are discussion forums, and these are files. By the way, you can model at different granularities. You could have, these nodes could have been individual messages, so who interacted through a message, or threads, or discussion forums, or you could even have just one big node representing all discussions. And in a year ago, a Hicks paper, my student did an analysis that went through these different granularities of analysis. So let's you do different granularities of modeling. And this is kind of interesting because this actor has all green arrows going in, this actor has all purple arrows going in. That means that this actor, was creating most of the discussion postings, and this actor was doing most of the file uploading, and they're interacting through them. So it shows you this kind of an interesting asymmetry here. Two people who are closely coupled, but in an asymmetric way. But we're not going to look at this level of detail. We're going to look at the larger community, or larger network. I have to use the right word at the right time there. So we selected 2 years of, from the tapped-in data where they had their peak activity. A lot of painful work on the part of my graduate student preparing the data. Dealing with things like mismatched timestamps and missing IDs in the log files and stuff like that. Through that process, imported them into our event format, which now makes it a lot easier to deal with the data. And so we imported data on chat forums, discussion forums, and file sharing. And the arrows are going to be representing accessing and contributing to one of these 3 artifact types. We filtered out some stuff that we weren't going to study. I guess in the interest of time, I'll not talk about that. So the resulting sociogram, again, this is a directed bipartite multimodal graph, which I call a sociogram because it represents the associations between people, and partly influenced by Latour again. Has 40,000 vertices and About half of them are human actors. The rest are artifacts. It has over 200,000 edges in the graph. The edges, by the way, are weighted by the number of times that the two actors were associated via the artifact. So it's always actor, artifact, actor. Anytime there's an event, anytime there's an event, it's actor, artifact, and you increment that weight every time you see an event. And so the associations between people are always mediated. So the sum of the weights of all the edges is actually the number of events being considered. So there's 20 million events being considered. We can look in more detail, and this is in the paper, if you want to look in more detail at how it distributes across media types as a whole. But what we want to do is make this kind of chart for specific clusters in the network to understand what kind of mediation is this particular cluster. Chats, of course, it's easier to type a chat message. People usually take more time typing a discussion message, so that doesn't really mean that people chat more than discuss unless you make that claim at a trivial level. The in degree for actors for artifacts is reads, and out degree is right, because out degree means it's pointing to the actor that, is that right? I get it mixed up all the time. Yeah, the actor that influenced it, and it's reverse for actors, and all the numbers add up right. Okay. Another interesting thing to look at is that the average path length is kind of surprisingly small, especially given that if you divide this in half to get the path length between human actors, it's really small. It's largely due to this tapped-in reception room. By default, a new account will log into that room, and then somebody will chat in that room saying, hi, do you need any help? And that puts a link in my graph. So that makes the path lengths really short. We actually had to do an analysis taking that room out to see if the results change. And the basic results were the same, except for one issue that I get two communities with it instead of one that I'll show you later. Okay, I should move on to the what the results were here. So again, what are we doing here? This is a network. The communities are embedded. We want to find them. We'll define them as cohesive subgroups that have some kind of identifiable common identity, purpose, or task. That's the part that's human interpretive. I have to look at it to see. We use what's called a community detection algorithm. This is kind of an overuse of the word community. This particular algorithm is a modularity partitioning algorithm. It takes all the nodes in the graph and it puts them in the partitions, which are not overlapping. That's what a partition is. But in partitions that are designed so that the linkage within a partition is greater than the linkage between partitions. That's called modularity. For you computer scientists, it's an NP-hard problem to get the guaranteed best solution, which means it's practically impossible. So we always do try to optimize towards, we try to approximate the optimal. And I use Gephi, which is a real nice new open source network analysis software because it handles large graphs and it's also a nice interface. And so then I looked at the properties of the high degree nodes in each partition. So find the clusters, figure out who's active in the cluster, look at it, see what they are. Okay? So here's a visualization of the whole network in an open ORD. There's citations to the Blondel's partitioning modularity algorithm and the open ORD layout algorithm. Both of them are designed to deal with these large graphs. If you run a traditional algorithm, it will take days. And this is too hard to look at. So one thing you can do is you can break out the cohesive subgroups, and we get ones of these sizes. We don't need to talk about the details here, but we can see that there's two big ones that are kind of, the layout algorithm puts closely related nodes close to each other. So we can see that they're, those top two ones are really closely related to each other. So let's first look at this P3, because it gives you an example of when it's easy to interpret something. We're going to dive in to look at the high degree actants. So I go into Gephi. These are the modularity classes. The colors are different because they always change the colors. You click on group, and your graph suddenly goes like this, which is not very helpful. But then if you click on data laboratory, note up here, you get folders. You open up a folder for that modularity class. You sort by degree or weighted in degree or whatever you want. Here by degree, suddenly every single high-ranked actor has the same organizational affiliation. So this network, the algorithm knew nothing about what these nodes are, and it was able to find that this is a very cohesive community within tappedin because they're all from the same organization. The top two ones are chat rooms in terms of degree. But because there's more chat events than there are discussion events, you got to be careful about saying that that means they just chat. It turns out they actually had fairly good use of discussions as well, a lot of reading discussions. So this tells you something about what their characteristics are. And then I went to my tappedin colleagues and they said, yeah, that school was a tenant. They had a communities of practice program mentoring new teachers somewhere in the Midwest. And indeed, all these actors were members of this school district. So that shows you how you can find that this one happened to correspond to a tenant, but you could discover communities that are in your environment. And also who is not a tenant who is participating. How do people cross over between different actual communities? So I got way too little time left. Interpreting the two largest clusters took more work because the role of tappedin reception, I'll just kind of step you through it visually. One thing I did is I applied a filter. I graphed just the high degree nodes. This is the reception room. These are the highest degree actors. And notice they have strong connection to the reception, but these partitioning algorithms don't allow overlapping communities, so it forces these to be in the different communities. But clearly they have a strong association. These actors are doing something in that room. And okay, you can read the papers for the details, but if you look at the first partition, the high-ranked actants are rooms, and they're all rooms that are owned by tappedin and that function to welcome and route newcomers to public venues. So I see this as the, and many of the actors, a high percentage, are only associated with this room. They don't have much connections to anything else. So I see this, and it's chat-based, yeah. And it's not really being a community, but rather kind of like the larger network for legitimate peripheral participation, if you wish, for where new people come in and they're welcome, they're directed to where they need to go. Whereas this other one that is closely related to it, the top actants are human actors who are the most active volunteers in the system. One of them wants me to tell you who he is. Jeff Cooper, north of Portland, wants to be acknowledged for his work. I asked him whether he minded my talking about his stuff. Sorry. Okay. And so these highly ranked actors are also related to a diversity of rooms owned by different tenants, but all of them were used to host these after-school online events. So we interpret this, and these two actors regularly facilitate these events. So we interpret this as where the community associated, if you will, you can argue about whether to use that word, but it's the collection of people that participate in these after-school online events regularly as facilitated by these two people. And then we go on to other ones. You can read about how I interpreted it in the paper, and I also dove into, I'm wrapping up now, small groups. One really interesting one was English as second language small course being run by an Australian sheep herder. So all kinds of people in here. Okay, summary. Purely structural graph theoretic computations identified cohesive subgroups that have interpretations as communities. Tappedin really is a great place, is one of my conclusions. It's a transcendent community in which smaller communities and communities embedded have kind of like a lot of overlap with each other that I want to analyze more with a better algorithm. The value to learning analytics is you want to know what social setting your learners are in, identify them empirically. We need an overlapping community algorithm, which I can talk about later. And we can dive in to examine the activity of high-degree actors, and I'm doing that in other work that I don't have time to talk about. Watch for this in future papers.
Okay.
Thanks.
Okay, we have 5 minutes for questions. There's a microphone, so be bold and step up. Yes.
Shout out. Well, there were, it wasn't all as easy. There were 170 something of them. I looked at the top 10. The top 6 are described in my paper. Many of the, after the 2 biggest ones, the rest of them that I looked at were fairly easy to interpret. And then I dove in and I looked at a bunch of small examples too. The top 2 were messier because it involves all the people that don't have a strong association with any particular organization or purpose, but they're coming in, they're wandering around, they're joining different things. And so that's why I interpreted the first one as sort of the fuzzier network, the transcendent community, if you wish, that's around all these more specific activities. So I don't know how to quantify easy. You have to sit there and look at your data. Nothing, in the end, it takes some looking at things.
Anyone else?
George.
Thanks, Dan. I'm wondering, with so much of the interaction going on in online spaces now that includes more than a text-based focus, so your analysis was text-centric. Have you considered looking at sort of the, and obviously any multimedia element could be an actant like any of the other points you referenced there, but have you looked more at sort of what's the impact from a multimedia perspective and how?
That's actually where this work came from. Originally, we developed these contingency graphs, not the sociograms, looking at students interacting through a whiteboard and a chat, and the whole idea of uptake came from that, because you can't analyze that situation using media-specific relations like reply or adjacency pair. So I came up with the idea of uptake so that I could look at cross-media stuff. And then we built, over a 2-year period, Nathan Dwyer, Ravi Vatrapu, Richard Medina, and I worked out an extended example and improved our notation to capture the interaction through both whiteboard and chat operations. Now, that was a manual analysis. Automating the whiteboard analysis would take some ontology of what kinds of moves there are. And actually, I think Ura Koppe did some, or one of your students did some work on this about 10 years ago about analyzing operations in a workspace. So there is work out there on that, and I haven't applied it yet to the automated part. Yeah, that's something I think we need to tend to more.
Okay, we have time for one more question, and I can start switching to the next speaker already. So
go ahead.
Dan, based on your present research, how much actually of the impact of the content itself, and basically have you considered the use of any kind of content analysis, especially given that you are working with large-scale networks?
Yeah.
So, you know, we are usually interested in knowledge construction in different levels of presence of learners in those communities.
Yeah, that's actually, I was kind of surprised that we got such good results here without really looking at content. But I think more at the level of interaction, that's where we're going to be applying it, where you're looking for a lexical and semantic overlap. But I'm not doing things like LSA. I think that's important too. And I'd like to figure out how to work it into this hierarchy, which wasn't really today's focus. But yeah, okay.
all right, thanks a lot.